Ladies and gentlemen, our next speaker has been named one of the nation's 100 leading innovators by the Smithsonian, as one of the 100 most influential people in defense issues by Defense News, and among the top 100 global thinkers by Foreign Policy. He's a strategist at the New American Foundation, a popular science editor, and is an official mad scientist for the U.S. Army's Training and Doctrine Command. He's a founding director of the Center for 21st Century Security and Intelligence at Brookings, where he was the youngest person named Senior Fellow in its 100-year history. A published author, among his award-winning books is his latest novel, Ghost Fleet, a novel of the next World War. Ladies and gentlemen, please welcome to the stage Dr. P.W. Singer.
So thank you for the very kind introduction and also the opportunity to join all of you here today. The organizers asked me to speak to the technologies that will shape the future of not just cyber conflict, but conflict overall. And I think that's important because in many ways they're meshed together. It's going to be hard to distinguish them. Now, the challenge in seeking to explore this is that I think our focus should not be on technologies that offer some kind of evolutionary improvement, a missile that goes a little bit further, a fighter aircraft that goes a little bit faster, but rather the technologies that change the game. They go by different catchphrases in English. They were once revolutionary technologies back in the Rumsfeld era. Now they're disruptive technologies. Weirdly, if you're outside the military, you call them killer apps. What we're talking about here is the next technologies that will be equivalent to the steam engine in the 1820s, the aircraft in the 1920s, or the computer in 1980. Now, there's an important warning here. We're not in the Rumsfeld era. What makes them revolutionary is not that they solve all your problems. Rather, it's the exact opposite. What defines these kind of technologies is that they give you a new set of questions that we don't have the answers for. And there's two types of these questions. The first is, what is possible that wasn't possible before, say a generation ago? And the second type of question is a little bit harder. It's what is proper, the issues of right and wrong that we weren't wrestling with a generation ago. And they might be the right and wrong way to recruit or train or equip, or the right and wrong doctrine, or they might be legal or ethical questions that we were debating at science fiction conventions a generation ago that now we're debating at military conferences and in military professional journals. And I think you can see many of those that have popped up, including in this conference here. Now, our studies show that there's many of these potential kind of technologies out there, but I think it's more important to break them into different types of categories. The first type of category is breakthroughs in hardware, specifically robotics and more autonomous, more intelligent robotics. But importantly, this future breaks into two different types that's reflected in how intelligence is handled in nature. The first of these are large-scale systems where the intelligence is centralized, and in many ways the technologies is offering sort of a direct replacement for a human role. The second is how in nature you have other species where the intelligence is networked or disaggregated. So each little individual ant, not all that smart, but together ants can do incredibly complex tasks. The same thing is happening when you look at a different direction with robotics. Now, what's important in this is that these kind of technologies in either direction offer up huge questions both for the future of war, but also for the future of work. And in that, they create a lot of extra dilemmas that come out of it. So for example, this is a shot from a Budweiser beer commercial that showed off during last year's NFL American football playoffs. And in it, it showed a robotic truck delivering beer down the highway. Now, I imagine a truck driver in one of these states where it's the most popular job, watching the NFL playoffs, sipping their bud, and not being excited by this commercial, but a little bit worried about it. And again, we can see these questions not just hitting truck drivers, but even moving into the military and the cybersecurity field. There's also changes in what runs and connects our technology, the bucket of software. This is playing out in all sorts of different ways that we've been talking about here. The Internet of Things, where it's not merely computers that are linked together used to communicate, but all of the objects in terms of their operations. Everything from smart cars, smart refrigerators, smart military bases, power grids, you name it. And the scale of this is growing to be immense. In fact, it's so immense we don't know the size of it. I've seen in studies estimates of it ranging from 30 billion in terms of things woven in to 126 billion over the next decade. The point is, we're going to see a lot of things woven together and operating in different ways. Another core change in the internet is the move to Web 2.0, social media, where we are all now collectors of information, but also distributors of information, whether it's through Twitter, Instagram, VK. And sometimes it's kind of funny. So we've got a lot of millennials in the room. The average millennial will take 26,000 selfies. But it's not just millennials. We have a baby boomer as president who's expressing more of himself online than has ever been expressed before. But this is moving into conflict. Every single conflict actor out there, be it ISIS, be it the Russian military, be it Chicago gangs, at the organizational level and the individual level, is telling its own story online, as well as all the civilians in the places where they're operating. Now, the result of that is that every single act of conflict is being talked about online, usually in real time. And that's whether we're talking about operations against ISIS to the Abbottabad raid, supposed to be the most secretive U.S. military operation of our lifetime. It was live tweeted by a Pakistani IT engineer who was up late at night, was woken up by helicopters, and did the new natural thing, started tweeting about it. However, in turn, as we've seen from Russian operations everywhere from Ukraine to the Baltics to Hungary to Brexit to now the United States, it's becoming easier to not just spread truth, but spread fiction, influence operations. So the outcome of this is that arguably there are no more secrets, but the truth is harder to find. Big data, more data than has been ever available before, but big data is the key word, but it means a lot of different things. One is just the mass number of sensors that are out there. So if you have things measuring in tens of billions, the number of sensors collecting data beyond the computer will measure in the trillions with a T. It also means where the data is stored. We're no longer keeping the data in the hard drive, in the phone, in the refrigerator. It's moving up into the cloud. That changes the story of everything from what we need to defend and the perimeters to the targets that hackers are going after increasingly in the future, to most importantly, it's allowing us new insights because you're bringing different forms and sources of data together and allowing you to learn things that wouldn't have been possible before. So it may offer new things in everything from business efficiency to cybersecurity in terms of detecting anomalies. It's also, however, creating new dilemmas and questions that we didn't have before. So as an example, I advise a major international bank, and through no active seeking out of the information on their own big data allowed them to find out the exact amount of rent that one of their customers would be willing to pay, and then the exact point that they would walk away from that monthly rent. They didn't seek out that information. It's just what they learned from bringing all of the different data together. It created a dilemma for the bank. Who do they owe? Do they owe their customers not to share this information? Or do they owe their shareholders? Hold it, we've just developed an incredibly valuable set of data. And again, you can think about the military dilemmas of trust that come out of big data collection. artificial intelligence, machine learning, machines that are not just able to mimic human decision making, but make superior decisions. Quantum, which may change not just the nature of computing itself, allowing, for example, 1 million times faster computing, but the potential of unhackable communications, in at least the way we've thought about it previously. Breakthroughs in what I call wetware. So if you have hardware, software, you have wetware. Human performance modification, or the science fiction version of this, think of it as Iron Man meets Captain America meets the Russian Olympic athlete program. All the different ways we're using technology to change us. So it's playing out with, for example, genomics, bioscience breakthroughs that push past our previous limitations in everything from endurance to focus and intelligence, to how we connect to our technologies, human-machine interfaces, where we're no longer using our little monkey fingertips to control our computers and all the things that are powered by them, whether it's cyber attacks to flying drones. Again, for science fiction fans, this is Clint Eastwood's 1985 movie Firefox come to life, but you don't have to learn how to fly or how to learn Russian to do it. And again, not sci-fi, there's the picture of it. The list goes on and on. Indeed, the fact that there's so many of these different kinds of technology categories that cross and shape each other is maybe what's most important and exciting. For example, direct digital manufacturing, or more popularly known as 3D printing, is bringing together both hardware and software. You're taking a bit, a computer design, and turning it into a thing. The ripple effects of that will, for example, it may lead defense contractors to experience what the music business did when the iPod came along. Utterly disruptive for everything from their supply chain to their plans for profiting, raising new intellectual property questions, you name it. What happens when soldiers are making their own spare parts? With so much change, it's too early to know what's going to shake out from this, but I think we can identify a few key trends that will matter, importantly, for conflict and beyond. The first of these is that none of these technology areas are inherently military or civilian. Both the people and organizations that fund them, that research them, that develop them, that buy them, that use them, cross both civilian and military, government and business, and you name it. Combined with greater machine intelligence, they're also easier to use. So these are not like a ballistic missile or an aircraft carrier. They will have incredible low barriers to entry, and they will be far more proliferated. Second, the United States and our close allies will be in a different situation when it comes to these technologies than what we've been used to for essentially the last 70 years, where we will face peers in terms of the technology itself, and in some situation, moving past us in technology capabilities. So as mentioned, I work with Popular Science, and we run a series that mines Chinese social media and the internet for their latest technology breakthroughs. And as you can see here, these are shots of everything from new civilian space launch programs to robotic warships to a 4 million square foot national laboratory for quantum information sciences. It cost about $10 billion. They just started construction on it. Compare that to some of the things that are happening, or rather are not happening in our own nations. Second, they'll make all conflict multi-domain conflict. Whether one is talking about battles with a state or a non-state actor, it will be different, again, than the kinds of battles that we've grown used to over the last several generations, where most of the operational space was on the land, and you saw kind of supporting roles in air and sea, but no battle for control of the air or control of the sea in the way that we experienced back in World War II. That's the last time. Indeed, the last time the U.S. Air Force had to fight against a peer, it was actually the U.S. Army Air Corps. Now, that'll also include battles in locations that we've never fought before. But again, the point is it will happen both against non-state actors, and when I say will, it already has. So in the Battle of Mosul, ISIS flew over 300 drone missions in 1 month 1/3 of them armed strike missions, to the scenario that we played out in Ghost Fleet was what would happen in terms of state-on-state conflict in the 21st century, where it, again, would be multi-domain and also would be against peers in a way that we haven't experienced. Fourth, a changed tempo of conflict, battle, and beyond. These new technologies create massive amounts of complexity and data. In turn, part of their appeal is that they can make decisions quicker than humans. So whether one is talking about missile defense or cyber conflict, the so-called OODA loop, observe, orient, decide, act, that defines, in essence, every activity, whether, again, in battle or in acquisitions, is becoming more and more inhuman. Next, this changed tempo will affect war overall. So it's going to be quicker in some ways, but in other situations, the most important battles will happen before the war even begins. So, for example, this is a depiction of what Russia did to Ukraine. Before the first little green men crossed the border, they'd already conducted operations that had a paralyzing effect, hitting everything from Ukrainian business to government to military communications. Or the timing of the attack might happen earlier than in a way that we've even come to expect. We, again, played with this a little bit in Ghost Fleet, the idea of a hardware hack, where what happens in terms of a cyber conflict against an adversary that makes all your microchips and networking equipment. So the most important battle, the most important decisions might have actually happened years ago. And finally, as this example shows, this would be number 7, we're only scratching the surface of what will play out in cyber and conflict beyond. So another key shift is in the type of attack. When we talk about this space, we mostly talk about using information to observe or to steal information or to block information, like, for example, what Estonia experienced back in 2007. But we've had very little use of attacks that change information. Really, we can only point to Stuxnet as that example, where this ability to change information is the true weaponization of it. All the other types don't cause physical damage, but when you gain access and change information, you can cause physical damage, and now you're talking about an actual cyber weapon that mirrors an actual weapon. And the point of this is not just that, we did Stuxnet. I can say it. Some of the people in the room can't. But the idea here is that we opened up a new realm of conflict, and where cyber weapons also differ is that they bring their own blueprint with them. So you can either direct copy them or use them for inspiration. And so we should expect the next cyber conflict, particularly against state actors, but maybe non-state actors, will see this use of attacks that change information and cause physical damage. Importantly, as you go back to some of these prior trends of the internet becoming more and more things and the use of more and more robotics and unmanned systems in both civilian and military worlds. 8th and finally, all of this technology shift does not mean that we will see humans eliminated from war anytime soon. Rather, just like the steam engine, the plane, the computer, we'll see changes in the human skills that are needed and are no longer needed, and the locations where humans might be located. And this movement of both people skills and people physically should change everything from our recruiting, our training, our organization, our doctrine, our structures, you name it. What I'm getting at here is that, again, we're just scratching the surface of the who, the questions that surround the who, not just around the attacker, but around the defender. And this kind of question is one that plays out both for businesses, governments, and militaries. And a big part of this is, in essence, trying to figure out what does our IT team, what do our cyber warriors look like? Where should they be located? And a big problem that we're wrestling with at New America in a project called Humans of Cybersecurity is the problem of the lack of diversity in what these people look like, because we're not going to be able to pull the right talent and organize them if it's not a diverse space. In sum, all of these issues, all of these technologies raise, obviously, big, deep questions. But maybe most challenging of all is how to build and maintain deterrence in a time of such flux. That is, our challenge is not just to adapt to these different technologies, but to understand how they affect what is needed to prevent aggression, miscalculation, and accidents, in order that we don't fight the wars of the future, but instead keep the peace. And that's why these kind of conferences and these kind of organizations are so important, and I'm really pleased to be able to join you for it. Thank you.
So we have some time for questions. So we have some people with microphones. So if you have a question, please raise your hand and we'll be right with you. There we go.
Thanks for coming, Dr. Singer. I'm JR with the University of Nebraska. One of the things that you mentioned is that more of these data-driven machine learning systems will kind of shape and change the role that humans actually play. And being that I work at a university, one of the things that I see is students are actually being prepared for positions that don't actually exist yet. Could you speak to that thought and that concept, and what role you see humans playing?
You hit it. There's two different. There's either preparing us for the world to come. What are the type of skill sets that might be needed in the future? And we can already see this. And again, this is a debate that needs to happen not just at the university level. That's too quick. So in the United States, the fact that most students don't learn sort of basic technology skills all the way down to the elementary school level is a shame. There's another part of this is that most of them don't learn cyber hygiene skills. And that continues. And again, it's not just, the challenge is not just within our field, but within all of the different related professions. So the example I like to use is when you look at law schools and MBA programs, most of them still don't teach cybersecurity as part of the regular coursework. And again, the point is not that everyone's going to go in the cybersecurity field, but in every MBA program, they teach you finance. You have to take an accounting course because it's going to be something you deal with. The same thing that if you are a business executive, you will be making some kind of cybersecurity decision for your firm. Same thing if, we've seen these changes within the military academy. So there's that kind of prep. One thing I want to put out there as the opposite, which is a question to the cybersecurity field: are we training people for skill sets that are not going to be needed in the future? So, you think of the example of what we've seen at conventions in Vegas, where you've got machine learning and AI doing bug hunting tasks that used to take skilled humans weeks or even months, and it's doing it in seconds. And you go, hold it, what kind of skills did we just show that are probably not going to be wanted 5-10 years from now that universities are pushing people out with? I just sort of want to put that challenge. Are we the equivalent of teaching the sailor how to tie knots when the steam engine comes along, even in this highly sophisticated, highly sort of technology cutting edge field? That's something we're going to need to wrestle with. And I go back to throughout this, my sense is we're going to need kind of a mix and match of skill sets. Actually, we were just having a conversation in the back about, and you could sort of see the same things if you're doing threat intelligence. There's some technical skills that are needed, but you also need the ability to kind of make sense of qualitative data to understand the why. Or if we're looking at how do we solve the problem of influence operations and fake news, everyone's looking to an algorithm to solve it, but it's actually part of it's also us becoming better consumers, and that's using better consumers of information, and that's using skill sets that actually come from the social sciences and humanities, not from the computer sciences.
Number 2?
I think many of us have read your other book besides Ghost Fleet, Cybersecurity and Cyber War, What Everyone Needs to Know. What has changed?
Thank you. And still available on Amazon.
Right, and I think many of us continue to...
For those of you that haven't.
What has changed since you published the book? If you were going to publish the book, say, in the upcoming 12 months, what would you include in it that wasn't there right now?
Gosh. I mean, I think the underlying frameworks and the issue, you know, the internet itself, how it works, the types of attacks, they've not changed. Certain of the issue areas have changed, and they range from, for example, you know, we had a chapter looking at the potential of kind of international norms and building towards laws. That clearly has taken a hit in the last couple of years, where we thought we had momentum building, you know, not just the United States, our allies, but Russia and China starting to use a similar language. And then we saw at the global group of experts meeting a couple months back just to pull back from that. A different example would be the story of hacktivism. I find it utterly fascinating that the US government's position towards Anonymous went from saying, you're the worst possible organization, et cetera, to when Anonymous starts swinging away at ISIS and op-ISIS, you start seeing senior US government leaders describing them as a great ally and a valuable thing. And again, you know, we sort of talked about that back and forth. I think it's a more graphic illustration. Certain people's individual story would change. At the time where we had the book, the story of Julian Assange was in a different space than it is now. We would update it for the Russian language edition. And this hits one of the other parts that I would add a chapter on influence operations and the like, or this is what my next nonfiction book is on, is looking at social media and how it's being used in politics, war, conflict, et cetera, and you know, looking at everything from the Trump campaign to Russian operations to ISIS, you name it, with the idea that we're seeing the same dynamics in these very different spaces. We think they're different, but they're not. So if we were looking at a book just on cybersecurity, I think it would pose the question that, you know, back in the 90s, within the US military and most of our allies, we had this debate about this new cyber stuff. Should it be separate and get its own organizations, or should it be part of kind of the information operations people? And the Air Force was a particular place where that played out. And ultimately they said they're separate. Private industry mirrored that decision. Maybe it was a mistake. Russia definitely did not separate them. China did not separate them. And I think you can see this play out in what Facebook is going through. So if you look at how, and it's not just Facebook, again, I said US military corporations, if you look at Facebook and its security team, it was all top cybersecurity experts in terms, and their focus was on defending our networks, our customers from being hacked. And they weren't looking for how will kind of their minds, how will the overall system be hacked. So their focus was in the wrong place throughout the 2016 election. And we can have sort of an argument about the why and what more they could have done, but the point is that maybe we separated them too much, and as a result, we've missed some of the bigger things going on, or at least certainly the way adversaries operate.
And I just wanted to add that it is a much beloved book, and we also have the other author of the book here at the conference as well, Alan Friedman. So thank you to both of you for being here.
And Alan's great. And I would add there's a project that he's working on that's another sort of area of change is what more does the Internet of Things mean? You know, the Internet, as I mentioned, has evolved. So we've got questions in securing the Internet of Things, some of which are similar and some of which kind of take us into new directions, and we're going to have to wrestle with that, and both, again, inside and outside of government.
I think we have time for one more question. Number one.
Sir, good morning. Mark de Wolf, Cyber Command, Netherlands, MOD. I have two questions for you. One is probably you're familiar with the recent dispute between Mark Zuckerberg and Elon Musk about the artificial intelligence threats. Do you want to contribute on that discussion? And the second one, I assume you're familiar with Nick Bostrom's superintelligence on his research. Do you share his thoughts about his concern controlling SI systems in near future when they're being developed?
So where I agree with those different figures is the realization of the importance of artificial intelligence is, again, one of these game-changing technologies, and the framing of it as, being something different than what previously has come along. Related to that, I applaud the fact that they're, in some parts of this debate, they're operating differently than how we previously did with technology, of assuming that it would only solve all of our problems. Again, you can go back and the story of everything from dynamite to electricity to the telegraph to Facebook, we're all supposed to solve all the world's problems. Now we're saying, hold it, AI is not just going to be big, it's going to open up challenges. Where I'm interested in, though, is, we always want to do the science fiction future of the robot takeover and the like, and that's a lot, the superintelligence that destroys humanity, et cetera. I'm more interested in the transition period. So a different way of putting it is, if this is the equivalent of the new, to use the phraseologies, the new industrial revolution, or the next industrial revolution, or however we frame it, go back to the previous industrial revolution. It didn't happen like that. It played out over years and decades. It spread in different ways, so to go to science fiction, the William Gibson, the future is unevenly distributed. The same thing will happen with this kind of technology. And it disrupted not just business, but as we mentioned, in the presentation, everything from labor forces to what those people then do in their lives, how they vote. So the Industrial Revolution, if you're telling the story of it, you could focus, go back to James Watt and just focus on the steam engine, or you could go, wow, the Industrial Revolution shaped everything from the rise of Great Britain as a world power to movements of people, peasants and craftsmen, to factories, the rise of cities, to revolts everywhere from Europe to, you can't tell the story of the many-faceted origins of the American Civil War without at some point mentioning kind of how the North and the South move in different directions, in part because of industrialization, and the North wins because of that. So the point is, it's a much bigger ripple effect, and that's what interests me, and I think we lose it in this kind of just focus on, will the robots destroy us or not, or the techno-optimist of, well, if it's bad, I can stop it. Because the other part would be, identify to me one technology that we didn't actually open up and check out and see how to use it, et cetera. And again, that's not a lesson from science. That's a lesson from, Greek mythology, Pandora's box, but also has played out with everything from the atomic bomb to the first person that said, ooh, this cool computer network, I want to test and see if I can spread messages through it through a virus. So that, to me, that transition and the ripple effects is the more interesting, more important part that we're all going to have to wrestle with. So again, thank you for, maybe that'll be that'll be the conference 10 years from now. So thank you.